I'm going to talk about some of the scaling functionality, which just started off as a talk about stuff that I'm working on now, and it turned more into a history kind of talk to give some context. So whatever, like 7 years ago, we had this dream, which we inherited from other workflow systems, of saying things like, well, Parsl's magically going to manage batch jobs, and it's going to scale the number of batch jobs you have to match your workflow needs. And that comes from this era where there were a lot of bullet points on slides and a lot of very rough prototypes. So we've got this phrase, trigger scaling events to match workflow needs. And there were other things in slides and documents that kind of implied that Parsl would both acquire more resources, more batch jobs, more worker nodes when it needed them, but also when it didn't need them, it would get rid of them. And that was not massively true, and it still is not massively true. So before 2020, there was a scaling method. It did not very much. The behavior was basically if your process is still running, but you're not doing any Parsl tasks, maybe you've gone off to do some local processing and nothing happened for 2 minutes, then it would scale down all of the batch jobs. And that was all or nothing. Either we're going to get rid of all of the batch jobs that we have, all of our workers, or we're not. Okay? And there was also the case that if a batch job failed for some reason, like it ran out of wall time or otherwise ended naturally, if there wasn't enough workload, if there weren't enough tasks to justify starting up a new one, it wouldn't get replaced. But there was nothing that said, well, we don't need this batch job and it's still got 12 hours of runtime left. That batch job would just sit there for 12 hours not being used. And that was enough for the sort of 2017 era. That's fine for saying we can put scale in as a bullet point on our slides and kind of hand wave it away. But it's not really very good, this. So I had some guesses, some thoughts about why we didn't push on this much more. And there's things like a lot of our simple workloads, they're not very bursty. You submit 10,000 tasks and that's it. And then you just let those 10,000 tasks run. So you're going to use a large number of resources until the very end. And then only at the very end, you're going to get a bit of tail off as you run out of tasks to do. And pretty much people just accept that. From the user side of things, really users only notice inefficiency when they start doing their own performance monitoring. Otherwise, it's just, oh, it ran, this is how long it took, whatever. It's from my monitoring work, it's really noticeable how much users don't pay attention to any kind of efficiency, which is what scaling is all about, is about efficient use of allocated nodes. And if you're not providing those tools, people just don't notice. And then as soon as you do provide those tools, people do start noticing and start asking for features. And we haven't traditionally provided any observability into node utilization in Parsl. We're better now than we used to be, but in the 2017 era, we didn't provide anything. So no one's going to notice these wasted worker nodes. Also, a bunch of users like Desk, they don't use block scaling in this way. They run their workloads entirely inside one batch job. So there's no notion of adding worker nodes or taking worker nodes away from a workflow. The whole thing just runs inside its own fixed allocation. And a lot of that was driven by there not really being a safe place to run your submit side code. Like if you want to run some batch systems, they would reboot all their login nodes every few days. So you would submit something into the batch system, and the batch system is going to run your task in 3 days' time. But in the meantime, your workflow process is going to get killed by a reboot. So there's motivations there to not run on a batch, not run outside a batch system and submit jobs in there. And there's a couple of HPC systems issues. So the feedback loop time is insane. If you're looking at hours worth of feedback from, I've decided I need one more resource, one more worker node. Now I'm going to submit a batch job, and in 12 hours time, 20 hours time, I'm going to get that worker node. That's a really long feedback loop. It's much cheaper to cancel tasks than to allocate tasks, and that asymmetry sort of encourages you to over allocate, because if you keep these worker nodes around, you don't have to go back in the batch queue for 20 hours to get them back again. You can keep them. And a lot of HPC systems are really hostile to granular resource allocation. So sort of for scaling up and down, the ideal resource allocation is one core. And I can say, all right, now I need 3 more cores, just give me 3 more cores. And now I don't need 2 of them, so I'll get rid of 2, but keep 1 of them. And HPC batch systems are policy hostile really to that. Their policies are structured around these big rectangular MPI jobs, where they're like, you can have 1,000 cores for 12 hours in one job. And the idea that you would have 1,000 jobs, each asking for 1 core, is absolutely horrifying to traditional HPC policy. Even though they're asking for the same resources, and even though 1,000 jobs of 1 core are easier to schedule or more fluid to schedule than 1 job of 1,000 cores. That's not always the case. Like IN2P3, this institute in France, has a high throughput cluster that only allows you to allocate 1 core. So the users that I work with there have different problems because they can only allocate 1 core. They can't allocate 20 cores or whatever. And the final guess is just people aren't interested in this. Researchers, at least researchers we work with, aren't interested in scaling up and down. Certainly our developers aren't. So that's sort of ideas of why this idea that sounds nice hasn't been pushed on in the last, say, 7 years of Parsl. So in August 2020, we got PR 1563, which introduced some better scaling. So that introduced per block scaling for the high throughput executor. So that could say, I don't need this block anymore, so I'm going to ask to scale it in. And that was necessarily by block, because that's the unit that we talk to the resource managers for. So if you're allocating a block of 1,000 nodes, well, you can only scale in 1,000 nodes at once. And the main limitation there was you can only scale in that block if all of the workers are idle in that block. So if I've got 1,000 nodes, I need all of those 1,000 workers to be idle. And there's nothing in the high throughput executor to direct tasks in such a way that if you've got 2 blocks and you've only got enough work for 1 block, there's nothing to say, well, let's direct all the work to the first block so that we can kill the second one. What you end up with is 2 blocks that are 50% allocated. So it's extremely rare for this scale down code to actually be able to scale in anything. But it is good for the 1 block equals 1 worker case, because your block is drained as soon as a worker finishes its task. It can be drained and scaled in.
Hey, Ben.
Yeah.
I just wanted to mention one quick thing.
Yeah.
I got a question from Kevin about what exactly is a block, and I just want to mention on an HPC machine,
Yeah,
when we
a block
say blocks, it means a batch job.
Yeah, a block is a batch job, basically. So a block is if you do a Q sub or an S batch command on an HPC system, that's what a block is the proxy for. In other cases, when you're not an HPC, when you're on your laptop, it's just a Unix fork. And on if you're running in Kubernetes or something like that, it turns into a Kubernetes job, I think, or some Kubernetes object. So scale in and scale out aren't symmetric. It's if you come and don't think about it too hard, then it seems like, well, scale out gets more blocks, scale in takes away blocks. They're kind of symmetric operations. And they aren't symmetric specifically because a scale out is making a block of workers that is idle, but a scale in has to deal with the fact that you have all these blocks of workers that are doing things. Right, so it's not symmetric. So you can look at this PR as a cultural artifact, which is something me and Dan Katz, who is not here today, I think, are doing a little bit more, looking at sort of development process and human factors and things like that. So PR 1563 was this good example of this style of contribution that I really want us to avoid, which is commit and abandon. That is, we put the commit in, and it's done, it's finished, rather than this being the start of a contribution. This is the end of contribution. So that code got put in. It basically hasn't been touched since. It had some bugs in it, of course, and they weren't fixed. The big thing that's bad here culturally is that these are bugs that affected users who didn't use this new feature. So I'm pretty happy with Parsl getting new features that are buggy, and we put a little test tube icon next to them and say, it's new, whatever, it's experimental, you're going to have your own adventure using it. But some of the bugs that this introduced broke behavior for everyone, even people who hadn't turned on this new scaling in feature. Culturally, one developer moved to FunkX, it was Jiadu. I think Zhuzhao was involved in this as well. He went off to China. So there's zero capacity for those original developers to come and fix the resulting bugs. That's a thing that I hope we can address with future PRs from contributors. And it's also, for me, the main driver when I'm a dick about, I'm not going to merge this PR yet. It is because I end up with the poop, like me personally. So I'm trying to persuade you to wipe up that poop before you fly away. So some of the bugs, I started working on this because I got some funding to fix some of these bugs. So we've got these 4 bugs that are open in GitHub Actions at the moment. There's a race condition on scaling when you hit Control-C or when you do some other termination. So the scaling code makes a blocking remote procedure call into the interchange to discover which blocks exist. If the interchange is gone because it's been killed, then that just hangs. And so the whole of Parsl shut down, all the other tidy up gets blocked on this interchange that doesn't exist anymore. So also a lot of the time that RPC is completely unnecessary, and it should go away. There's a race condition where sometimes a scaling can happen to kill a block, but another part of Parsl has seen that the block has got idle workers and it's given those workers a task. So you end up with this race condition where a task gets submitted and then suddenly the worker gets killed because it's been scaled in. We don't encounter that much because scaling doesn't happen very much, but if we got more scaling happening, I think we would see that more. There's a weird one which causes all kinds of trouble. This is probably the one that's most frustrating, which is htext doesn't scale in blocks that haven't registered yet. And that's related to the first bug because it only scales in blocks that have registered with the interchange. So if you've got a block in the queue, it's not going to scale it in, it's not going to delete that job from the queue. So that results in users, if they cancel a workflow, if they kill a workflow, they'll end up with a bunch of not executed yet queued Slurm jobs or PBS jobs that will just stay in the queue. Parsl won't delete them. It's also this mad combo bug 3019 that I figured out the other day, which is a combination of 3 different bugs. We have expended many tens of thousands of dollars of professional time, babysitting, hanging CI runs that come from this particular bug. And then the last one is HTEX. When it is trying to scale in just a few blocks, it does it in a weird order. It sorts them by idle time in the wrong direction. So you can ask why sort them at all. I'm not entirely sure why or what that code is doing. Again, it doesn't really affect people because scaling isn't really happening. So the work I'm working on, this is what I originally was going to talk about in my talk. I've got some funding to work on this. The primary deliverable is to not leave batch jobs in the queue. So this one here, scaling all known blocks, not just the ones that have registered. That's the main point of what I'm working on. But on the way, I'm removing a couple of dead code paths. I've fixed up some doc strings a bit. This is not particularly well tested, so I'm trying to get my head around how to test this because it's pretty awkward to test. Scaling in one block when you've got 5, and then you're like, let's somehow change the load so that we only need 4. That's awkward. I'm having, as part of that, I'm going to look at the ordering of blocks when we do scaling. Like for unsubmitted blocks, I think it's pretty clear. I think that I want to scale in more recently submitted blocks before longer ones, because the ones in the queue longer are going to run first. The submitted block policy, I'm not really sure why they were being ordered. And then stuff I'm not going to do from those previous bugs. I'm not going to deal with this interchange blocking RPC at scale down. Ideas there in the future might be separate out a scale down everything at exits method versus a scale down a small number of blocks in a live system call, because those two concepts are jumbled up together at the moment. I think they might be separate. You might end up with treating the RPCs between the executor and the interchange in a way that doesn't block so much. Like you might accept that this is a grown-up distributed system and it needs to behave like a distributed system, and not make RPCs as if they're in the same process. And the other thing that's not in scope for now is changing job allocations to try and help blocks drain more easily. I think that could be quite straightforward. It might be an interesting project to mentor with someone if I find them. Yeah, so that's what I'm planning on doing to address the stuff that I just talked about.